Hello everyone, and welcome to all of you to our channel Schrödinger's Cat. So here we'll discuss here the TIFR 2023 Physics full question paper solution. So first of all, in TIFR, the total number of questions, that is the 40, in which two parts, section A and B, 25 plus 15, and the strategies, the mathematical physics, the total number of questions are coming 4, classical mechanics 5, EMT 5, quantum mechanics 5, thermodynamics and statistical physics 4, electronics 4, condensed matter physics 1, wave optics and oscillations 5, nuclear and particle physics 3, and it is general physics GP, that is the 4th. Okay, this is the strategies. And the section A, that is the 25 questions, in which the carrying, this is basically plus 3, and the section B, that is for 15, this is for plus 5, and the section C, here is 15, this is plus 5. So total, that is the total 150 marks. Okay. And one thing is that here the part A is common for both integrate PhD and PhD students, PhD aspirants. And part B and part C, part B for integrate PhD and part C for only PhD. So for PhD A and C, and for integrate PhD A and B. These are the strategies of the TIFR, Tata Institute of Fundamental Research, and the TIFR 2023 question paper is conducted by the TIFR Hyderabad. So let's get started. That the first question number 1, a surface is given by 4x square y minus 2x y square plus 3z cube equal to 0. Which one of the following is a vector normal to the point 2, 3, 1? First read out the question carefully and give me the solution of this question by commenting the answer, and after look upon my board for the elaborate solution. First try yourself. So here this is given that the gradient of f, grad of f, that is the xyz at the point 2, 3, 1. This is nothing but the del f del x I, del f del y z plus the del f del z k at the point 231. Okay. So this is equal to differentiate. You would get the partial differentiation 8xy minus 2y square I plus 4x square minus 4xyz 4xyj plus 9z square k. Okay. So now put this value. This is at 231. You would get that the 30i minus 8j plus 9k. Option A is correct. 30i minus 8j plus 9k. Next. Question number 2. The value of the first derivative of the function fx equal to 2 by root 3 e to the power minus root 3 x square mod x at x equal to 0 each f dash 0 is what? First try yourself and give me the solution by commenting. So here it is given that the this equation is basically the Gaussian distribution function. This type of. Okay. So fx is what? 2 by root 3 e to the power minus root 3 x square mod x. This is written in the form that the 2 by square root 3 e to the power minus root 3 x cube when x range 0 less than x less than infinity, and the 2 by root 3 e to the power root 3 x cube when minus infinity less than x less than 0. This is the two part. So now solve f dash x at x equal to 0 plus. This is nothing but minus 2 by root 3. Okay. 3x square root 3 e to the power minus root 3 x cube at x equal to 0. This would become 0. Now f dash x at the point x equal to 0 minus. This is basically the limit x tends to 0 plus minus. This will become 2 by root 3 into 3x square into root 3 e to the power root 3 x cube at x equal to 0. This would become always 0. Thus, the f dash 0 would be 0. F dash 0 would be 0. Basically, this is y, origin and the x. F dash 0 would be 0. 0 would be the correct answers. Option A is correct. Next, go ahead. Question number 3. Consider a symmetric matrix M, an orthogonal matrix O, which can diagonalize this matrix by an orthogonal transformation. O transpose MO is given by O is what? So let us solve mathematical physics matrix topic, that the determinant of the matrix minus lambda I, that is 0. Put this value 1 by 3 minus lambda 0 1/3. 0, 1 minus lambda, 0. 2/3, 0, 1/3 minus lambda, that is equal to 0. You would get the eigenvalue that first you should calculate the eigenvalue and eigenvector. That the first of 1 minus lambda, that is 1/3 minus lambda whole square minus 4/9. This is equal to 0. And another for 1 minus lambda, 1/3 minus lambda whole square minus 4/9, that is equal to 0. These are two equations. So eigenvector for lambda equal to 1, that is for k equal to 1, for k1 you would get the 1 by root 2, y equal to 0, and 1 by root 2, 0, 1 by root 2. And for k1 equal to 0 and for k1 equal to 0, you would get the value of the 1, y, that plus 1 into 0, 1, 0. For lambda equal to minus 3, the eigenvalue is basically the lambda 1, next minus 1/3 and 1/3. See eigenvalue. Next for lambda equal to minus 1/3, you would get 2/3, 0, 2/3, 0, 4/3, 0, 2/3, 0, 2/3. This is equal to what? XYZ. This is nothing but 0, 0, 0. That implies that x equal to minus z and y equal to 0. Next for lambda equal to plus 1/3, that would become the k1 0 minus k1. Calculate yourself. So now for k1 equal to 1 by root 2, it will become, put this value here, 1 by root 2, 0 minus 1 by root 2. Okay. Thus, the O matrix become what? 1 by root 2, 0, 1 by root 2, 0, 1, 0, 1 by root 2, 0, minus 1 by root 2. So finally, our option A is correct. This will be the correct matrix. Next problem. Problem number 4. A small body of mass m is released from rest at the top of a frictionless curved surface as shown in the figure and permitted to slide down the curve. At the end point C, the tangent to the curve is horizontal. The mass then falls on the ground at a distance d as shown in the figure below when the experiment is carried out on the surface of the earth. The height h1 and h2 are also shown in the figure. Suppose the same experiment is repeated on the surface of the moon, where the acceleration due to gravity g dash equal to g by 6, where g is the value of the earth, the corresponding distance d dash at which the mass will fall on the ground in the moon is what? Very important questions, conceptual. So here, try yourself and feedback me the answer. Here, the conservation of energy, that means the kinetic energy half mv square, that is equal to potential energy mg h1. So the Vx would become square root of 2g h1, and the h2, that is the half gt square. This is nothing but the t equal to square root of 2 h2 by g. So the now d dash would become vt vxt, that means 2g h1 into 2h2 by g, that will become 2 square root of h1 h2, that means it would become d. D would be the correct answers. D would be the correct answer. Option A is correct. Next. A particle is executing simple harmonic motion in a straight line. When the distance of the particle from the equilibrium position is x1 and x2, the corresponding values of the velocity are v1 and v2 respectively. The time period of oscillation is given by what? Simple question, class 12 concept. That the speed or velocity v1, that is the omega square root of a square minus x1 square. So the v2 would become what? The omega square root of a square minus x2 square. So v1 square minus v2 square would become omega square x2 square minus x1 square. Okay. Omega square means twice pi by t whole square. And here the x2 square minus x1 square. That is the t equal to twice pi square root of x2 square minus x1 square is divided by v1 square minus v2 square. So option A here will be the correct answers. Next, a solid cylinder of uniform mass density rolls down a fixed inclined plane without slipping. The fraction of the total kinetic energy of the cylinder associated with its rotation about its center of mass is what? Try yourself and give me the feedback of the answer first. Then look upon my solution on the board. So here, the total kinetic energy is equal to translation kinetic energy and the rotational kinetic energy. That is, the K is nothing but half mv square plus rotational half I omega square. So put this value half mv square plus half I means half mr square. Omega means v by r. Put here v square by r square. You would get 3 by 4 mv square. So the rotational kinetic energy R, that would become the half of half mr square into v square by r square. This is what? 1 by 4 mv square. Now, the rotational kinetic energy by r plus k, that would become 1 by 4 mv square divided by 3 by 4 mv square. It would become 1/3. Option A is correct. Next, go ahead. Consider an electron double slit experiment as shown in the figure below with slit S1 and S2. If now within the speed region marked C, a constant uniform magnetic field pointing outside the base is turned on, the fringe pattern will be what? This is just theoretical question. Okay. That here, this is given from the waves. Topic, oscillation wave and optics. That means here the solution, the V velocity is in direction Vi cap and the B here Bk cap. So the force F, that is the Q V cross V. So you will get that E VBJ. Okay, thus the pattern will shift in the Z direction. Pattern will shift in the Z direction means will get shifted. Option A is correct. Next, an atom of mass m at rest emits or absorbs a photon of frequency nu and recoils with a momentum p. The frequency of the internal transition of electron level is nu naught without accounting for recoil. Assuming the process is non-relativistic, the fractional differences between the photon frequency for emission and absorption, nu minus nu naught by nu respectively, are given by what? This is basically from the particle physics, nuclear and the particle physics topic. So the energy conservation, that the A is nu is equal to A is nu naught plus p square by 2 and the momentum conservation A is nu by c, this is p. Okay, energy momentum conservation. So here put this value, A is nu equal to A is nu naught plus p means A is nu whole square divided by 2 mc square, that is equal to nu minus nu naught divided by nu, that is equal to minus A is nu divided by 2 mc square. So the emission, this is the absorption. The emission, it will become that the energy conservation A is nu naught equal to A is nu plus p square by 2m. So put this value, A is nu naught equal to A is nu plus p means A is nu whole square divided by 2 m means 2 mc square. That is equal to nu minus nu naught divided by nu, that is equal to minus A is nu by 2 mc square, or therefore nu naught minus nu by nu, this will become A is nu by 2 mc square. One is for absorption and the emission. That option A is correct. So emission is positive and the absorption, emission is negative here and the absorption should be positive here. Okay, that the next questions. Question number 9. Consider an electron with mass me and charge minus e, spin half, with spin angular momentum operator is given by S h cross by 2 sigma. The electron is placed in a magnetic field. At time t equal to 0, the electron is at rest in the SZ h cross by 2 state. The earliest time when the state of the spin will be orthogonal to the initial state. Okay, try yourself. So here it is given that this is from the quantum mechanics, spin topic, quantum mechanics. So here, Hamiltonian of the system, the Hamiltonian, this is H, is nothing but minus mu dot B. This is equal to minus T minus E by twice M H dot B. This is equal to Z by 2M mod of B H dot B vector by mod of B vector. That is equal to ZE by twice M, put this value of the S, that is the h cross by 2 sigma dot n. Okay. Sigma is the polyspin matrix. Here the sigma is sigma xi, sigma yj, sigma zk. And the n, that is the sin theta cos phi I plus sin theta sin phi j plus cos theta, spherical polar coordinate system. Now the eigenvector that the cos theta exponential minus I phi sin theta, and the exponential I phi sin theta and the minus cos theta. The eigenvector correspond to the eigenvalue. This is a matrix, spin matrix of this spin algebra. So the eigenvalue, this is the eigenvector, calculate from the matrix corresponding to eigenvalue, that is the E naught B and minus E naught B. This is what the first eigenvector phi 1, kit phi 1. This is the cos theta by 2 exponential minus I phi by 2. And the another one sin theta by 2 exponential I phi by 2. And the another kit phi 2, that is the minus sin theta by 2 exponential minus I phi by 2, and the sin theta by 2 exponential I phi by 2. These are the two eigenvectors. So now the eigenvalue of the Hamiltonian, these two, where the E naught is what? Here the E naught is ZH cross by 4M with orthogonal orthonormal eigenvector that phi 1. So initially, this is the calculative type question. Initially the state is what? 1, 0. That is the ket psi. This will be cos theta by 2. Okay. Exponential I phi by 2. Acting on ket phi 1 minus sin theta by 2 exponential minus I phi by 2 acting on ket phi 2. Calculate this one. So 1, 0, that means the ket psi, this is equal to cos theta by 2 exponential I phi by 2 acting on ket phi minus I t by h cross time evolution minus sin theta by 2 exponential minus I phi by 2, that is acting on phi 2, okay, into exponential minus I et by h cross, which is time evolution. Time evolution means psi 0 to psi t multiply by exponential minus I et by h cross. This is the time evolution. So now the psi naught and the psi t inner product. So this will become the exponential minus I t by h cross plus exponential I t by h cross, that will be 0, or the cosine of E t by h cross will become pi by 2, or the t would become pi h cross by 2 ic. This will become the pi h cross divided by 2 e naught b. Okay, that will be pi h cross 4m is divided by twice e z h cross mod of the b, that is equal to twice m e z mod b. Twice m e z mod b. This will be the correct answers. Option B would be the correct. Okay. Here this is wrong. Initially, that means it will never be orthogonal. It will be the wrong. Option B would be the correct. Question number 10. The electric field line due to a uniformly polarized dielectric sphere. Polarization along the positive z-axis is shown in the figure. Will look like this figure. The direction of polarization is from negative to positive charge. Negative to positive. Direction of the polarization. However, the direction of the electric field, positive to negative. Positive to negative. Direction of electric field. This is the concept. Very important. Direction of electric field. So, suppose this is plus minus within direction. The polarization should be this one, P. That is here this one, this is So option A is be the correct. Option A is be the correct. Next, a beam of unpolarized microwave radiation is incident along the x-axis on a grid of metal wire in YZ plane with wires running along the y-axis. In the width of each wire and the spacing between the adjacent wire is less than the wavelength of the microwave. The observation would be that what? From the oscillation wave and optics, thus theoretical question, the direction of polarization is perpendicular to the direction of the propagation as well as the perpendicular to the direction of the chain of wire. This is a basic concept of polarization of EM wave. So the transmitted wave would be polarized along the z direction. Simple theoretical questions. Next, very interesting. Consider the following situation. A uniform magnetic field B pointing into the plane of the paper is presented everywhere inside the rectangular region shown shaded in the adjoining figure. Outside the rectangular region, there is no magnetic field. A closed loop of conducting wire is placed inside the rectangular region as shown in the figure at time t equal to 0. The loop is then rotated counterclockwise with an uniform angular velocity omega about an axis perpendicular to the paper passing through the point O. If the direction along PQOP is taken to be positive, then a correct path for the EMF epsilon generated in the loop is what? From the EMT electrodynamics, so the induced EMF here, the induced EMF, that means induced EMF epsilon, this is d phi dt. This is nothing but B dA dt. So dA dt is constant. So A is uniform. Thus epsilon is constant. From the Faraday's law, we know that the system opposes the change in flux. Since flux through the loop decreases as rotates out of the magnetic field, so the EMF will be induced in a direction will increase the flux. That means the EMF will be induced in a direction which will increase the flux. That means here this is decrease, increase. This will be the correct because by the Faraday's law and the Lenz's law says, so this will become the oppose the incident flux. Okay. Now, next questions. Question number 13. Consider a sealed but thermally conducting container of total volume V, which is in equilibrium with a thermal bath. At temperature T. The container is divided into two equal chambers by a thin partition, which is thermally conducting but impermeable to particles. One of the chamber contains the ideal gas, while the other is a vacuum. If the partition is removed suddenly and the ideal gas is allowed to expand and fill the entire container, then once equilibrium has been reached, the entropy per molecule will increase by amount of what? Simple question then. Let us assume the V2 is 2V1 because volume is increased twice. That means this capital sigma 1 by capital sigma 2 is equal to V1 by V2 to the power n. Okay, this is nothing but sigma 1 by sigma 2 is equal to 1 by 2 to the power n. We know the entropy with the microstate that the S1 kb ln omega 1 ln sigma 1, and for two system this is nothing but the kb ln capital sigma 2. So this will become the kb ln sigma 1 plus n kb ln 2. That means the S2 minus S1 divided by n, this will become ln 2. kb ln 2 would be the correct answer. So option A is correct. Next question. Five identical bosons are distributed in energy level E1 and E2 with degeneracy of 2 and 3 respectively. Find the number of the microstate if there are 3 bosons in the energy level E1 and 2 bosons in the energy level E2. So the number of ways, simple, just apply the formula. The number of ways, that means the pi I n plus g minus 1 factorial divided by n factorial g minus 1 factorial. This is the formula for the bosonic system. So 4 factorial into 4 factorial divided by 3 factorial, 2 factorial, 2 factorial. So this would become 24. 24 option A is correct. Next. A two-level system with zero ground state energy is in equilibrium at a non-zero finite temperature. If alpha is defined, the ratio E square expectation divided by E expectation square, while the E denote the mean energy and E square expectation denote the mean square energy, then which is correct? From the distribution, thermodynamics and statistical physics. Here, the Z is what? Z is 1 plus e to the power minus beta ei. So the E expectation is minus 1 by Z dz d beta. Put this value. So e to the power minus beta ei divided by 1 plus e to the power beta e. So the E square expectation, this would become minus 1 by Z d square Z d beta square. So it will become, just do derivative, beta e 1 plus e to the power minus beta. So alpha is defined by E square expectation average, E average square. Put this value here. So here the E square e to the power minus beta e 1 plus e to the power minus beta e divided by 1 plus e to the power minus beta e into E square e to the power minus 2 beta e. Now calculate, or the alpha would become 1 plus e to the power beta e. Alpha is 1 plus e to the power beta e, that means the range of alpha is 2 less than alpha less than infinity. 2 less than alpha less than infinity. Option A is correct. Next question, question number 16. 16 means 16. The pulse chain at the output of an XNOR gate with the 3 input A, B, C will be what? XNOR. That means simple A XNOR B. That is what? A bar B bar plus AB. Okay. Here the A, B, A XNOR B, C and A XNOR B, XNOR C. The combination. Put this 1 value. So first of all, 1. It will become 1. It will become 0. It will become 0. Now 1. Next combination. 1. For 0. 1. You just calculate by this form. Next 0. That is 0, 1, that is 0, 1. This is 0. Next the 1, 0 means 0, and the 1. 0, 1. 0, 1, 0. 0. Put in the operation. I just written in the first line. 0. 1, 0. And the last one, 0, 1. That means the 0, 1. So the corrected answer would become the 0, 1, 0, 1, 0, 1. This will be the correct. Option A is the correct. Next. In an experiment setup, positively charged particles are detected by a detector which requires a negative DC high voltage of minus 2K volt. Every time a charged particle is detected by the detector, it gives a transient pulse of height 10 millivolt. The data collection system used for the experiment needs to detect its pulse. However, it cannot operate at minus 2K volt. Which one of the following circuit can be used to connect the delta connection system to the detector to obtain this pulse? That data collection acousticism requires a voltage less than this is given minus 2K volt. So it is impossible to do that by connecting a capacitor parallel to a detector voltage source circuit. This will be wrong. Because the capacitor is not be connected in the parallel to the detector. Okay. This in the parallel is not be connected. So series should be the correct. The capacitor will act as battery with voltage difference less than minus 2K volt. Question number 18. A faint star is known to emit light of a given frequency of an average rate of 10 photon per minute. An astronomer plans to measure this rate using a photon counting detector. If she wants to measure the rate of an accuracy of 5%, approximately how long should be the exposure time? Simple. Assuming the incoming photon follow the Gaussian distribution. That means the accuracy is equal to 1 by root n. That is accuracy 0.05 whole square is 1 by n. Okay. That is equal to 1 by 10 into 5. 5 minutes. Okay. 5% accuracy. So, or the 10T is equal to 10,000 by 25, or the T will become 40 minutes. 40 minutes would be the correct answer. Option A is correct. Next, in a mercury vapor lamp, an electric arc passing through mercury vapor produces light. When the lamp is switched on, the arc is stuck and the liquid mercury starts in vaporing as the temperature gradually increases. In a certain experiment, a Michelson interferometer is set up with a mercury vapor lamp as the light source, and the lamp is switched on. Which of the following effect will be observed? This is theoretical questions. Homework for you. Homework number 1. You just read out and theoretically answer this. Number 20. A beam of photon of 1 mega electron volt energy is shot at a 10 millimeter thick lead wick. Given that the density of the lead is this one and the atomic mass, and also that the interaction cross section for these photons with the lead atom is this is given. So the fraction of incident photon that will cross the brick without losing any energy is what? Very important question. It is also for your homework. You just apply this formula. I equal to I naught exponential minus mu x. X-ray skin depth formula. Okay. You will apply and do calculation. Homework 2. Simple question. 1 or 2 line. The following Fraunhofer diffraction pattern was observed in an experiment. The aperture arrangement that would yield such a fringe pattern is what? This is from the diffraction, wave optics and oscillation. This is another theoretical question, so you can do this. Homework number 3. Next, an electromagnetic wave is described by the following expression. Which of the following correctly describes the waveform? The equation of the standard equation, standard wave, that the uxt, this is nothing but twice a sin kz cos omega t. But the amplitude depends on the position and also the function of t. Here this is a equation clearly shows that there is a superposition of two standing waves having perpendicular state of polarization with equal amplitude for a given z at time. Also, it is mirror of the right circular polarized light, that is left circularly polarized for the standing wave. Because the phase is 0, phase is twice n pi by 2, twice of n plus 1 pi by 2, and the pi by 4. This is linear polarized, LP. This is elliptical polarized. These are the circular polarized, left-handed and the right-handed negative. This is the condition. So by this phase, the phi, the left circular polarized standing wave along the positive z direction. Okay. Next, question number 23. The minimum energy required to dissociate a hydrogen molecule H2 into two atoms is 4.5 electron volt. If the electron affinity of the hydrogen atom is 0.75 electron volt, the minimum energy required to dissociate the hydrogen molecule into H plus and H minus would become what? Atomic physics. That the process 1, H2, H plus H. This is the E1, 4.5 electron volt. Second process, H2, H plus electron. This is the energy 2, 13.6 electron volt. And the process 3, energy release. These are to the energy required. And this is energy release. That H plus E minus. This will become H minus. Here the energy E3. What? This is given all up. 0.75 electron volt. Now the net energy E1, net energy E net, E1 plus E2 minus E3. This would become 17.35 electron volt. Simple. 17.35 electron volt. Next. Question number 24. The binding energy EB of a nuclide XZ with atomic number Z and A is given by the semi-ampere mass formula. For the constant parameter and the source of effect for each term are given. What is the mass difference between the two mirror nuclei? It is known that both of them are spherical in shape and have a uniform charge distribution. Simple, just calculation. This is given. The mass, that is what? ZMP plus the NMP minus the binding energy by C square. This is the mass. And the binding energy, this is what? AVA, this is given. Semi-empirical mass formula. 2/3 minus AC, Coulomb energy interaction term, plus A minus twice Z whole square by A. So for carbon, that is the aim of 6 arrow. Okay. 6 MP, 7 Mn minus binding energy by C square. This is equation 1. And for the nitrogen, this is what? 7 and 13. Okay. 7 MP plus 6 Mn minus binding energy by C square. This is the equation number 2. So now, equation 2 minus equation 1, you would get the M of 1713 minus Mn 613. This is equal to Mn minus Mp plus AC 7 square minus 7 minus C square plus 6 divided by C square. Put this value. This will become 939.57 minus 938. Put this value. 28 plus 0.7. This will become the 7 square minus 7 minus 6 square plus 6 is divided by here the 13 to the power 1/3 mc square. Okay. So this will become 2.62 mega electron volt. 2.62 will be the correct answers. Wait. A relativistic particle moving in a one dimension x start from the rest at x equal to 0 and is subjected to a uniform and constant force field along the positive x direction. If the dashed line corresponds to x equal to ct, which one of the following curves, red line, would best represent the position of the particle? This is from the special theory of relativity, STR, classical mechanics. So the trajectory of the particle should lie below the dashed and cannot cross the dashed line. This is because dashed line can be taught of a trajectory followed by the massless particle moving with c. This will not, and this will not, because here this is the limiting order and here does not cross, because the dashed line represent followed by massless particle moving with c. So it cannot be touched. So option A will be the correct. Next, section B. A random positive variable x follows a exponential distribution p proportional to exponential minus lambda x with lambda greater than 0. The probability of observing an event x greater than 3 average expectation x, where the average x represent the average value of x, is what? Mathematical physics probability. So here the p equal to k constant e to the power minus lambda x. Total probability is 1, p total 1, that means k integral 0 to infinity e to the power minus lambda x dx is 1, that means k by lambda is 1 or k equal to lambda. So now x average, that the lambda 0 to infinity x e to the power minus lambda x dx, that the lambda by lambda square 1 by lambda. The probability of observing event at x greater than 3 average x, this is what? The probability p lambda integration 3 by lambda to infinity e to the power minus lambda x dx. Just mathematical calculation. Lambda minus lambda e to the power minus lambda x and the 3 by lambda infinity. Put this value, upper limit and lower limit, you would get 1 by e cube. 1 by e cube would be the correct answers. Number 2. Consider a regular tetrahedron ABCD as shown in the figure below. Let the point O be its center. The value of the angle AOB must be what? AOB, this angle. This is from the just geometry, mathematical geometry class 11 or 12. So this is for yours. Homework number 4. Do yourself and feedback me writing the answers. Next, a thin equilateral triangular plate of uniform mass density is attached to a fixed horizontal support along one of its sides. So a frictionless hinge as shown in the figure below. The vertical distance between the rod and the lower tip of the plate is h. If the pointed tip of the plate is displaced so that its plane forms a small angle with the vertical plane passing through the rod. The angular frequency is omega of the resultant motion, omega equal to what? Just calculate. Let us consider the side of the triangle. This is A. So we can write A equal to twice h by root 3. So this is equal to h by 3. So the moment of inertia about the centroid, the Iz, this is what? M by 3 r square, means the A by twice root 3 whole square into 3. That will become m a square by 12. The moment of inertia about the center of mass perpendicular to the plane Iz dashed m a square by 12, where the A is what? Twice h by root 3. So the distance of center of mass from any base, distance of center of mass from any base, this is what? A by twice root 3, that is equal to h by 3. Okay. So from the perpendicular axis theorem, Iz is Ix plus Iy. Put this value. Ix is Iy. That means the Ix equal to ma square by 24. This is equal to m in terms of h, ma square by 18. So the moment of inertia of plate about an axis passed through the hinge, we can use the parallel axis theory. I equal to ma square by 18 plus m a square by 9. That is equal to 3m h square divided by 18. That is equal to ma square by 6. The plate is executing pure rotation about the hinge. Now the equation, conservation of energy, that the energy is half I theta dot square minus mg h by 3 cos theta. That is E equal to half ma square by 6 theta dot square minus mgh by 3 into cos theta. Total energy of system is conserved. That means the d dt, that is equal to m a square theta double dot divided by 6 plus mgh by 3 sin theta dot. This is equal to 0. Or ma square theta double dot by 6 plus, just calculation, mgh by 3 theta equal to 0. Or the theta double dot plus 2gh by theta, this is 0. Or this will become what? The omega square root of 2g by h. Omega h square root of 2g by h. Option A is correct. Next, question number 4. A spherical planet of mass m, radius r, and uniform density is rotating anti-clockwise about an axis passing through its center, which is in the figure below is normal to the plane of the paper. The duration of a day on that planet is t. A small associated of mass m approaches the above planet from far away with a uniform speed v1 along a straight line at a perpendicular distance r1. From the center of the planet, see in the figure. This path gets distorted by the gravitational field of the planet, and the asteroid leaves with final uniform speed v2 along a straight line at a perpendicular distance r2 from the center of the planet. It is observed that after the passage of the asteroid, the length of the day on the planet has changed by delta t. Del t is what? So in this problem, the angular momentum of asteroid is not conserved. So we know rate of change in angular momentum is equal to external torque. This torque is produced change in angular velocity of planet due to the increase between the planet and the asteroid. That means the dl dt, this is I alpha, is nothing but 2 by 5 mr square d omega dt. That means dl equal to 2 by 5 mr square d omega. So the mod of dl, this is the 2 by 5 mv square twice pi by t square mod dt. That means m v2 r2 minus v1 r1. This is equal to 2 by 5 mr square twice pi by t square dt. That means dt or delta t would become 5m t square within bracket v2 r2 minus v1 r1 divided by 4 pi m r square. Option A will be the correct. A particle is in the ground state of a one-dimensional box minus L by 2 less than equal to x less than equal to plus L by 2. The uncertainty product del x del p for this state satisfy what? Okay. So for a given system, it is defined that the expectation of x is 0 and the expectation of x square, this is equal to L square by 12 minus L square by 2 pi square px average expectation, this is 0, that imply px square expectation equal to y square a square by L square. Now the del x del px is equal to L square root of 1 by 12 minus 1 by twice pi square into pi H cross by L. This would become 0. Calculate 0.57 H cross. 0.57 H cross means the del X del P within the range H cross by 2 and the H cross. Option A would be the correct. Next question. Problem number 6. Consider a diatomic molecule with two atoms of masses 1 and 8 mm, which are separated by a distance r and bound by effective interaction potential, that is the Vr, epsilon a to the power 4 by 4 r to the power 4 minus b square by 2r square, making a small oscillation approximation. The transition frequency corresponding to the vibrational spectra of the molecule is approximately what? Very fine question. Here, the dVdr is 0. That is the R 1 Armstrong is given. Second order derivative d square v dr square. This is nothing but the k, because Vr is given a to the power 4, 4r to the power 4 minus b square 2r square dVdr d square v dr square to 1. So k means k is what? Epsilon minus r to the power 2. This is epsilon 1 Armstrong r minus 2, and mu is reduced mass m1 m2 divided by m1 plus m. Calculate. This is the half amu. That means half amu means 1.6 into 10 to the power minus 27. This is in the kg. That the omega would become d square v dr square, second order derivative, divided by mu. This is the formula. Omega is basically the second order derivative d square x. D square is a function, okay? D square, suppose function of x by the dx square divided by m. This is the formula. Here m should be reduced mass mu. Put this value. That means the function is 1 by 2 pi square root of d square v dr square at the point r equal to 1 Armstrong. This is like this is coming in the classical mechanics small oscillation. Put this value, you would get 1.2 into 10 to the power 14 hertz. 1.2 into 10 to the power 14 hertz. A would be the correct answers. Next question. Question number 7. Consider a solid sphere of radius r with a total charge q distributed uniformly throughout its volume. The electric field measured at a distance x equal to 2r from the center of the sphere along the equatorial plane is found to be E1. Next, the same charge is distributed differently, such that the q by 2 is connected or concentrated at the north pole, and the remaining q by 2 is concentrated at the south pole. See figure right. The electric field is measured again at the same point on the equatorial plane and found to be E2. The value of the E2 by E1 is what? Here the E1 is what? Q by 64 pi epsilon r square. Electric field formula. and the E2, that is 2q by 2 cos theta 4 pi epsilon r. R means 5 r square. Cos theta because making an angle within theta. This is component of cos theta. Now, the cos theta is 2 by root 5 by this triangle. So, E2 would become what? 2q by 2, 2 by root 5 divided by 4 pi epsilon 5 r square. That would become q divided by twice pi epsilon naught into 5 root 5 r square. So the E2 divided by E1 will become 8 by 5 root 5. 8 by 5 root 5 would be the correct answers. Next question. Question number 8. A small satellite S has a rectangular solar shell of diameter 8 meter cross 4 meter, which propels the satellite upon receiving the sunlight. One half of the shell is a perfect reflector, while the other half is a perfect absorber, as shown in the figure. Assuming uniform sunlight incident normally on the shell with an intensity 1370 watt per meter square, and ignoring the satellite's shadowing effect, the instantaneous torque experienced by the satellite is what? Classical mechanics topic, subtopic classical mechanics, subtopic torque. Intensity can be written in the form power by the area. That means, or P equal to IA. P means the FC equal to IA. So the force, here F is the force. So force can be written IA divided by C. So F means tau. Tau is R cross F. Okay. That is IA by C, because here F, that the tau, put this value IA by C, that means twice 1370 4 into 4 divided by C. C means 3 into 10 to the power 8. That will become 1.46 into 10 to the power minus 4 Newton meter. Option A would be the correct. Next question. Question number 9. The question are much long, 5 or 6 line, but the answer is very short, 2 or 3 line. The equilibrium temperature T0 on the surface of a planet results from the balance between the energy received from their host star and the energy they emit back into the space. In the case of the Earth, T0 is 300 Kelvin and the orbit is almost circular. We may safely assume that the planets absorb and emit radiation like perfect black bodies. Now consider an exoplanet of the same size as the Earth, which orbits a fainter star having a power output only 25% of that of the Sun. In an almost circular orbit of radius 25% that of the Earth-Sun distance, the equilibrium temperature T0 dash on the surface of its exoplanet will be about what? Same formula, I is P by A. That is 16 PS divided by 4S. So this will become 4PS by S. That means PS by S means I, intensity of earth. Put this value 4 into 300 to the power 4. This is equal to T to the power 4. So T would become 300 into 1.41. It will become 424 Kelvin. So 424 Kelvin would be the correct answers. Next question. At what value just a minute. At what value of RF will the ideal op-amp shown in the figure provide a gain of 6? Simple, just formula. Vs is equal to voltage input into 5 by 5 plus 1. This is the V input into 5 by 5 plus 1 means 6. Non-inverting amplifier here. Non-inverting amplifier means here the negative terminal, the feedback within the negative voltage. So non-inverting. So the V output is equal to 1 plus RF by 2 into V in into 5 by 6, or the V output divided by V into, that is the 1 plus RF by 2 into 5 by 6. This is 6, or the RF equal to twice 36 by 5 minus 1. This will become 12.4. 12.4 kilo ohm will be the correct answers. Next question. A well collimated constant current electron beam of Gaussian energy distribution centered at 10 electron volt with full width half maxima. Full width half maxima. This one. Full width half maxima means this distance of 2 electron volt is detected using a metal cup connected to an ammeter as shown in the figure below. The entire apparatus is kept in vacuum. To measure the energy with the graph of the current I versus V stop would be what? Homework number 5. Theoretical questions, do yourself and feedback me the answers. I usually solve you the numerical problems. This question is coming basically. A diffraction grating spectrograph is used to resolve the 2 sodium D line in the first order of diffraction. If the width of the grating is 2 semi and the focal length of the spectrograph camera is 20 semi, what the linear separation at the focal plane of the 2D line will be above. That the del y, the formula is what? Del y equal to dm delta lambda divided by d. This is nothing but dm delta lambda by lambda. Put this value 20 into 0.6 divided by 589 nanometer. This will become 6 micrometer. Option A would be the correct. Next question. A photon of frequency nu I collides head on means the head on means the two collides in the same direction. With an electron of mass m having speed ui and the photon scattered off in a direction exactly opposite to its initial momentum, see in the figure. It is found that the frequency of the scattered photon is the same as that of the incident photon. Which one of the following conditions must hold for this to be happen? This is from the particle physics. Here the given interaction that the gamma plus electron, So you can write the momentum pi is nu I by c. Let us assume the linear momentum of incident electron. This is minus p. And the scattered electron, this is the plus p. Thus, linear momentum conservation pi minus p, that is equal to minus pi plus p. So p equal to pi. This is equal to h nu I by c. So option A is correct. The magnitude of the initial momentum of the electron, that is the PIE, is h nu I by c. Next question. The number of hyperfine state found in the 3 helium atom for the electronic configuration 1s1, 2s0, 2p1 would be what? Hyperfine structure, atomic, molecular and laser physics. L1 is 0, L2 is 1, that means the capital L, 1. S1 is half, S2 is always half, that means the S is 1, 0 and the another S is 0, that means the L 1 means simplify total angular momentum J is 1. So I, that is half for the helium 3, that means the F value C by 2 and the half. Now S is 1, L is 1 and J is 2, 1, 0. S is, this is one configuration, S1, L1, J2, I half, F 5 by 2, 3 by 2. Another combination, S1, L1, just write permutation combination, class 12, J1, I half, F 3 by 2, half, Next S1, L1, J0, I half, A half. So the number of configuration would be in this state 1 is 1, 2 is 0, 2p1 would be 7. Option A is correct, 7. Because the total 7 F value are obtained from the different state. Total 7 F value. F means S, P, D, F. F orbital. Basically the spin. Third component of isospins, I3. Okay. Next. An X-ray of wavelength lambda when incident on the 101 plane of a cubic lattice with lattice constant A produced a first order Bragg reflection at theta equal to 30 degree. Suppose this cubic lattice is compressed along the z-axis such that its lattice parameter along the x-y axis remain the same, while that the along the z-axis become 1 by root 3a, seen in the figure. The first order reflection for the 101 plane of the compressed lattice occur at theta equal to 1. Very important question. By the Bragg's law, 2d sin theta. This is equal to L lambda, n is 1, or twice the sin 30 lambda, or lambda is a by root 2, because a is equal to b equal to c. A equal to b and c equal to a by 3 square root 3, and the twice d dash sin theta dash equal to lambda for the second one, or the sin theta dash would become a by root 2 twice a by 2. 1 by root 2. 1 by root 2 means what? Theta dash 45 degree. 45 degree would be the correct answers. 45 degree would be the correct answers. Next question, section C. A complex analytic function omega equal to fz transform an equilateral triangle in the complex z plane to another equilateral triangle in the complex omega plane as shown in the figure. Which option below cannot be exact? That is the fz e to the power 5 pi I by 6 twice I root does not map the coordinate triangle z plane to the triangle omega plane. You just map this to one is z plane and the omega plane. Mapping. You check. Homework number 6. You check it. A would be the correct answer. Just map 1 to 1. 1 to 1 means z plane mapping with the omega plane. Next question. Calculate the integral. Integration 0 to infinity dx by root x square plus 1. Basically, it is written in the form 1 by root x square plus 1 dx. This is the correct method of written. Basically, I. So, substitute x equal to tan theta. Dx is sec square theta d theta. Now, 0 to infinity 1 by root x square plus 1 dx. This would become 0 to pi by 2 sec square theta d theta divided by sec square theta root tan theta. That will become 0 to pi by 2 cos to the power half theta sin to the power minus half theta d theta divided by 1. You will now use the gamma function. Gamma m, gamma n by gamma m plus n. Gamma function, this will become the gamma 3 by 2, gamma half divided by 2. This would become the pi by 4. Pi by 4. Now you check here, the pi by root 2 is correct, pi by 4 is coming. You check this solution. Okay. Simple. You check this calculation. Just single. Puts x equal to sec theta and x to theta. Limit change here. That for 0 to 0. And here infinity pi by 2. Question number 3. Consider the Hamiltonian for one-dimensional classical harmonic oscillator. Classical oscillator. A canonical transformation to variable pq via the generating function f m omega q square by 2 cot q reached to reach the following Hamiltonian in the new coding. Canonical transformation, classical mechanics. The F1 is what? M omega square q square by 2 cot capital Q. Now, the del F1 del Q, that is equal to minus P. So, M omega square q square by 2 minus cosec square q, that is the minus P. It implies that q equal to twice P by m omega square sin q. Now, del F1 del q, this is the small p, that implies, just calculator, do derivative and calculation. Cot q equal to p. Put the value of the q. Put the value of the q. Q is what? Square root of twice p by m omega square into sin q. One will get the small p m omega p cos q. So k equal to Hamiltonian h plus del f1 del t where the del F upon del T is 0. So the K means Hamiltonian would become the Hamiltonian. The new Hamiltonian is defined by the Hamiltonian K. This is the P square by 2 m plus half m omega square q square. Now we'll put the value q equal to twice p divided by m omega square sin q, and the small p is m omega capital P cos q. We will get the Hamiltonian is omega p. Or the Hamiltonian is given 1 by 2 m p square plus m square omega square q square. So the F would become m omega q square by 2 cot q. So P would become del F del q. Just to differentiate, it would get m omega small q cot q. And the capital P would become del F del q. It will become m omega q cot q. So the capital P, that is the minus del F del q, that is the m omega q square divided by 2 cosec square q. Okay, now put in the Hamiltonian. Hamiltonian would become m omega q whole square divided by 2 m cosec square q. So it will become m omega square q square by 2 cosec square q, basically the omega p. Therefore, the Hamiltonian is omega into p. Omega into p, just calculation. Hamiltonian is omega into p. Option A is correct. Next, question number 4. A simple pendulum is oscillating freely in the vertical plane. If the string is shortened very slowly to half of its length, the angular amplitude theta max will change by the factor of what? Very important question. Energy should be conserved. Simple concept. That is, the mg 1 minus cos theta max, this will become mg L by 2 1 minus cos theta dash max. That means twice sine square theta max by 2. This will become sine square theta dash max by 2. Or 2 sine square theta max by 2. That is equal to sine square theta dash max by 2. Or 2 to the power half sine of theta max by 2. This will become sine theta dash max by 2. Or this will become 2 to the power half theta max by 2 is equal to theta dash max by 2. Or 2 to the power half theta max is equal to theta dashed max, theta max dashed, or the theta max dash is equal to 2 to the power half theta max. So the factor is 2 to the power half. That means the root 2. B would be the correct answer, root 2. Next, consider a particle of mass m in a quadratic potential. Quadratic potential means x to the power 4. If we take a variational wave function exponential minus lambda x square with lambda greater than 0, try to estimate the ground state energy. The value of the lambda should be chosen as ABC. So you may use this integral form. Okay. Variational principle, quantum mechanics. Psi is given here, a e to the power minus lambda x square. Simply normalize this. Minus infinity to infinity. Mod psi square d psi dx equal to 1. That is equal to minus infinity to infinity a square e to the power minus twice lambda x square dx is 1. That is a square root of pi by twice lambda is 1, or you would get the a square value twice lambda by pi. Now the expectation value of the Hamiltonian is what? 2 lambda h square by 2m minus 4 lambda square h square by twice m a square by 2 square root of pi by 8 lambda cube plus 3 by 4 a square alpha square root of pi. Put this value only, nothing to that, lambda to the power 5. So rearrange this. This will become 2 lambda h square by twice m minus 4 lambda square h square by twice m. Here 2 square root of twice lambda by pi into pi by 8 lambda cube 3 by 4. Put this value of a only, okay? Capital A, 2 lambda by pi alpha square root of pi by 32 lambda to the power 5. That means, or dd lambda of expectation of is, this is 0. That implies that h cos square by m minus h cos square by twice m plus 3 by 16 alpha minus twice by lambda cube, this will become 0. So you will get the value of the lambda 3m a by 4 h cos square to the power 1/3. It will be the correct answer. Option A would be the correct. 3ma by 4 h cos square to the power 1 by 3. Okay. Now go ahead, our second problem. Next problem, question number 6. A charge E is moving with an angular frequency omega along a circle of radius A, always keeping a small distance d from a grounded infinite conducting plane. The leading dependence of the radiative power p omega at a distance r greater A will be what? Simple. P is qxt and the xt is a cosine of omega t. So p dot, this will become minus qa omega sine omega t, and the p double dot will become minus qa omega square cos omega t. Simple. So the p double dot, that expectation square, a average square, q square, a square, omega to the power 4. So the p omega proportional to omega to the power 4. Option A would be the correct. Next question for yours. Theoretical question. I think this will become the homework number 6. Theoretical questions for yours. Waveguide EMT. For an electromagnetic wave propagating through a rectangular waveguide, the electric and magnetic field will become what? Next problem, problem number 8. Consider a fermionic system with an Hamiltonian. This is given. Consider the grand canonical ensemble of the system at temperature T and zero chemical potential, where Kb is the Boltzmann constant. The grand canonical partition function of the system is given by what? Very important question. Hamiltonian by given this equation. The secular equation. The secular equation becomes the determinant of 0 minus lambda, E naught 0, E naught 0 minus lambda, twice E naught. Diagonal matrix basically. Upper diagonal and the lower diagonal are the symmetry. 2 E naught 0. This is equal to 0. So the eigenvalue would become the lambda. You calculate, it would become 0, root 5 E naught and minus root 5 E. For one particle system, the microcanonical, we get the partition function z1 e to the power minus 0 plus e to the power minus beta root 5 E naught plus e to the power minus beta root 5 E naught for one particle. For the two particle system, this would become the z2 e to the power minus 0 plus e to the power minus beta root 5 E naught plus e to the power beta root 5 E naught. For two particle system can be written as, for microcanonical, that the Z3 is equal to 0. So collection of all microcanonical is called the GAN canonical. Okay. Collection of all microcanonical is called the GAN canonical. That is the Z1 plus, this is always 2 particle. Z2 plus Z3. This is nothing but 3 plus twice e to the power beta root 5 e naught plus 2 e to the power minus beta root 5 e naught. You will get after calculation 3 plus hyperbolic cos root 5 e naught by kt. Kt be the thermal energy. Option A would be the correct. Next question. Question number 9. A half-adder circuit is defined as two input, two output logic circuit where the output S gives the sum of input up to a single bit and the output C gives carryover a single bit. The truth table of half-adder is given. Which one of the following circuit doesn't behave like a half-adder? Does not behave like a half-adder. So here the sum of half-adder is what? A XOR B, and the carry of the half-adder, this is sum. C means the carry. A and B. A and B means this one. But the form of the configuration of the figure A, we get the S AB C AB. This is we get by the figure. Figure means that is given. So which is not correctly provide the same output of the half-adder. So let us assume the one. Here this is AB. This is A AB. Basically the AB. Here that is the B AB. That is the AB. So here S is AB and C is AB. So option A would be, let us choose ABCD option. A option would be the correct. Next question. In an experiment of measure of angular distribution of the emission of particles, the angular distribution function is defined as the f theta is n theta by n pi by 2, where the n theta is the number of particles detected at an angle of theta. If for a certain sample we count n pi by 4 is 1, 16265 and the n pi by 2 is 819, then the uncertainty derived by f at theta equal to pi by 4 is this measurement at theta equal to pi by 4 would be approximately what? This is for yours homework number 7. This is for numerical question. You calculate this and feedback me the answer, and if you not done yourself, I give you the answer in comment box. Next question number 11. The energy gap between the n equal to 1 and n equal to 2 energy level of a hydrogen atom is denoted E naught. Now consider a muon carbon ion C5 plus, that is a carbon nucleus orbited by a muon. The energy of the photon emitted in the transition of the muon from n equal to 3 level to n equal to 2 on this ion will be approximately what? This is from the atomic and laser physics Bohr theory. Try yourself first and give me the solution by comment. This is the beauty of the live class. Here this is given that En dashed En dash equal to mu by mass of electron into En. That means E naught equal to 13.6 into 3 by 4 into 1836 1837 electron volt. That means the 1 electron volt equal to 4 into 1837 into E naught divided by 1836 into 13.6 into 3. That is the En dash of C12. This is mu by me En. That is equivalent to E equal to 12 into 1836 into 208 into 12 1836 plus 208. Put this value only 13.6 36 into 5 divided by 36 electron volt. Just calculate 12 into 1836 into 208 divided by 12 into 1836 plus 208 into 13.6 into 36 into 5 by 36 into 4 into 1837 into E naught divided by 1836 13.6 into 3. You would get the final result that the 1400 E naught. Option A would be the correct. Go ahead, our next problem. Very important. A lattice in the three-dimensional space has n sides. Is occupied by an atom whose magnetic moment is mu. The lattice is in contact with a heat reservoir at a fixed temperature T. The atoms interact with an applied magnetic field H equal to H chi z cap, ignoring the interaction between the atoms. The average magnetic susceptibility for lattice side is given by what? This is the H. This is mu. This angle is theta. Here the Z1. This is nothing but 0 infinity to twice pi integral 0 to pi e to the power minus beta e sin theta d theta d phi, because this is sine component. Okay, so this will become twice pi integral 0 to pi just a minute. Just indicate yourself. So it will become 0 to pi e to the power, put this value of e plus beta mu h cos theta sine theta d theta. Let us assume the minus beta mu h cos theta is t, that you would get the beta mu h sine theta d theta. This is dt. Now the z1 is equal to twice pi integral minus beta mu h upper integral beta mu h 1 by minus beta mu h e to the power minus t dt. Okay. So this will become, you calculate, you would get the 4 pi by beta mu h sine hyperbolic beta mu h. You would get this result. So for n particle means Zn to the power n. It would become the 4 pi by beta mu h sine hyperbolic beta mu h to the power n. Simple. So now the energy U minus 1 by z del z del beta. And U is what? And the U is minus beta mu h divided by 4 pi sine hyperbolic beta mu h into 4 pi divided by mu h. Here would become cos beta mu h into beta mu h minus sine hyperbolic beta mu h divided by beta. Calculate. So you would get, or you would get the value of the U n kBt minus of n mu h for hyperbolic beta mu h. And the F is what? Minus kt ln z. So this is minus nkt ln, put this value only and the mathematical calculation. Beta mu h sine hyperbolic beta mu h. So you have to find the magnetization at the z direction. Then you should value the value of the chi. So it would become the minus del f del h, simply do the derivative, minus nk t del h of ln 4 pi beta mu h plus ln sine hyperbolic beta mu h. Solve this, you would get this value n kt minus 1 by h plus cot beta mu h into beta mu h. You would get this result. So now mz average, this is nothing but n mu cot hyperbolic beta mu h. Just put this value, just kt mu h. So maximum of mz, this is mu. So the mz, this will be mu x. That's the mu square h by 3 kt. Now you would get the value of the chi susceptibility, that would become mu square by 3 kBt. Mu square by 3 kBt would be the correct answers. mu square by 3 kBt. This is the 5 marks question. So this is very long calculation. Mu square by 3 kBt. Next question. Question number 13. 13, 14 for yours. Okay. The angular position of a star is found to change by amount of 0.2 arc second when measured by telescope on the earth on two different nights separated by the exactly 6 months. Note that the distance between the earth and the sun is known to be approximately 1.5 into 10 to the power 13 cm. If the energy flux received from the star is F 10 to the power minus 7 arc per second per semi square, what is the approximate value of the luminosity in arc per second? This is for the classical mechanics, special theory of relativity. Homework number 8 for yours. Next problem. The binding energy EB of a nuclide X is A to the atomic number Z and mass number A is given by the semi-ambiguous mass formula. Where the constant, parameter and source of effect of each term are given in this table. For a spherical neutron star consisting of only neutron and having uniform nuclear density throughout its volume, the Coulomb term is repeated or replaced by gravitational energy. What would be the smallest radius of the neutron stars? Here just apply, this is for the cell model, nuclear and particle physics. Smallest radius, we apply the Coulomb interaction. F equal to Q1 Q2 by 4 pi epsilon naught r square. Force is given by the mutual binding energy. You would get the value of the R. That the R is Q1 Q2 by 4 pi epsilon F to the power half. You calculate, put in the value of the formula, calculate yourself and feedback me by commenting the answer. And if you don't solve it, message me. I will give you the exact solution. Today's last questions. Question number 15. The figure below shows on the right a sketch of an electron-positron collider experiment where the innermost detector is a tracking system which records the tracks of the change particle which pass through it. On the left on the figure, a cross-sectional view of the same tracking system is shown. The narrow pipe in the center is where electron and positron are injected as shown in the figure, collide in the center. On the left, it appears as a small central circle. Inside the tracking system, there is a strong uniform magnetic field, collinear with the electron-positron direction. If one of the E plus E minus collision means positron-electron collision, a high energy case not meson is produced that the subsequently decay as follows. K naught is to pi plus to pi minus. A possible representation of the track, the dotted line of the pion pi plus minus in the tracking system will be what figures. This question is very long, 10 lines, but the answer should be very short, 2 or 3 lines. The radius of the cyclotron motion, that the r, mv by qb. Since pi plus and pi negative are oppositely charged, they will rotate in the different direction. If pi plus rotate in the clockwise, then the pi minus rotate in the anti-clockwise, or vice versa. So here option A should be the correct, because these two are symmetry. This will not, because these two are in the same direction. Okay. Here it will not be. Here this will be the one is clockwise, and the another counterclockwise, or the anti-clockwise or counterclockwise. Okay. So we now complete our TIFR Physics 2023 full paper solution. So last but not the least, thank you very much. Stay well and happy. Have a nice day.